Hello. Today we're going to talk about arithmetic sequences. I think you'll like this. I always like the arithmetic sequences. So hopefully that'll make sense to you. So in your big space on your notes, I want you to copy down this sequence. And we're going to do some work with it. And before we get too far in it, I want to point out that this little 3 dots right here, is called an ellipsis. So those right there are called an ellipsis. And all it means is that there's more terms that are not listed. So we just didn't take the time to list them all. So it keeps going. You probably already knew that though. So let's talk about this sequence. I think you can probably figure out that to get to the next term, we're adding 9 each time. So that's what that would look like. So the next 2 terms, we would want to add 9, and we'd want to add 9 again. And that would give us 37 for the first one, and then 46 would be the next one. I think most of you could do that on your own. But what if I said to find the 20th term? We would have to make a big long list of numbers until we hit the 20th term to figure out what it is. Well, that might be fine for 20 terms, but what if I said to find the 2000th term? Would you really want to make a list of 2,000 terms? No, none of us would. So we want to find a more efficient way of doing it, and that's what algebra is all about. So let's turn this sequence into something we can do algebraically. So to start with, this is called our first term. This would be our second term. This would be our third term, and this would be our fourth term. And if I want to find the next term or the second term, I can take the first term and add what I call our common difference. In this case, it would be 9. So our first term is 1 plus 9 would give us 10. This one, I could take my first term and add 2 common differences, because 2 9s would be 18 plus 1 gives me 19. And to find my fourth term, I could take the first term plus 3 common differences. 3 times 9 is 27, plus 1 gives me 28. Well, notice that I'm taking the number of common differences that's actually 1 less than the term. So in the fourth term, I use 3 common differences. In the third term, I use 2 common differences. And in the second term, I used 1 common difference. So what that means is that to find the nth term, or any term in the sequence at all, I can take the first term and add it to 1 less than the term I'm looking for times the common difference. Okay, and hopefully you can see that pattern in what we just did. So again, if I want to find the 20th term, that would be a sub 20. I can take the first term of 1 plus 20 minus 1, or 19, times my common difference of 9. That ends up being 19 times 9, which that ends up being 171 plus 1 gives me 172. So the 20th term of this sequence is 172. And again, if you made a big long list, you could prove it, that that is what it is. So let's take a look at a few things here in your notes. An arithmetic sequence will have a common difference. That's your constant rate of change, same as your slope. It can be increasing or decreasing. Okay? And then this is the really important thing. This is the formula you're going to use to find the nth term of an arithmetic sequence. We'll use that a lot in this lesson. So here's an example. In this case, there's a common difference of 2. And so yes, this is an arithmetic sequence because it has that common difference. Here's example 2, where we're going to write an equation for the nth term. Well, again, we need 2 pieces of information to do this. We need to know what our first term is, and in this case it's 12. We need to know what our common difference is. In this case it's 3. We start with the formula, substitute in what we know, the first term and the common difference, and then we need to simplify it. And so to find the nth term, we use 3n plus 9. Okay, try those next Actually, I guess it's the next 6 questions on your handout. So do numbers 1 through 6 and come back here and check your work when you're ready. So here's the first 3. Yes, yes, and no. There's the next 3. Most everybody has no trouble with those first 6 questions. Those are pretty straightforward. But now number 7, let's do this one together again, just because this is sort of new for us. So here's our sequence. My common difference is 2. My first term is 1. And I'm going to start by writing the formula. And again, writing that formula at the beginning of doing every problem is really helpful because the more you write it, the more you learn it. So let's finish this off. Our first term is 1. And our common difference is 2. Then let's distribute. And then let's simplify. Okay? And so to find the nth term, we would be doing 2n minus 1. Now, I have a habit of always writing it with my variable term first, and that's because as we move into linear equations, this will be our slope. 2 will be our slope, -1 will be our y-intercept. So if you always get in the habit of writing your variable term first, it can really help. Now go ahead and try 8 and 9 and come back here to check your answers. Okay, you can pause here for a minute and check your answers on 8 and 9. And then let's move on to this last example. Here's just more of a real life scenario. If we have 20 seats in the first row of the balcony of the auditorium, and there are 22 seats in the second row and 24 seats in the third row. Our first term is 20. Our common difference is 2. We start with the formula, substitute in what we know, multiply it by our common difference of 2, distribute, and simplify. So to find the nth term, we would use 2n plus 18. And then if we want to graph that, we can use that to make a table, and we would find all those points. Notice that it makes a straight line. Notice that it crosses the y-axis there at 18, which is what I said our y-intercept would be. Okay? So how many seats would there be in the 15th row? Well, if we want to find the 15th row, we would say a sub, sorry about that, a sub 15 is equal to 2n, hold on a minute, let me back up. Where's my eraser? Okay, so to find the 15th, I would do, now I'm still on my eraser. A sub n is equal to 2 times the 15th row plus 18. That gives me 30 plus 18, which gives me 48. So A sub 15 is equal to 48. So the 15th row has 48 seats. Okay, and that's all we have to do. See you in class tomorrow.